All right, boys and girls, so we are beginning module 6. Module 6, a little bit, module 6, lesson 1. So module 6 is about decimals. It's called decimal fractions. We're basically bridging the gap from fractions that we have been doing and working on a lot to decimals. So all fractions can be converted to decimals. You know how I always said it's like, like 1/2 is really 1 divided by 2. And when you do that, you would create a decimal when you actually do the division part. We're not doing it that way. We're just kind of bridging the gap from what we know of fractions and turning them into decimals. So today's work, we're supposed to, actually, I've never been able to do this lesson properly because I'm supposed to have 10 bags of rice in a digital scale. I do not have 10 bags of rice, but I'll draw it a little bit. The Embark video might have the rice, I'm not sure. Anyway, so I'll get to the problem. I'm not doing the problem set yet. I'm actually just going over some of the concepts in the book that I would be teaching you if we were in class right now. So we're not going to jump right into the problem set. All right, so I'm going to have, this is going to be my digital scale. Okay, digital scales usually have, I don't have a digital scale at school, but they usually have like a little part here. The numbers are usually probably red. This digital scale is going to show 1 kilogram. And I have 10 bags of rice. So we'll pretend we have 1, 2, 3, 4, 5. I'm going to have, this isn't going to work very well, is it? 6, 7, 8, 9. Okay, well, our 10th bag of rice is up there. All 10 of these equals 1 kilogram altogether. So the question is, how much is each worth? Well, if this whole thing is 1 kilogram, then what would 1 be? Okay, so think about it. We divide it into how many parts? 10 parts. So that's 10 parts, and they're each worth 1/10. Now, if I had drawn this correctly, I of course would have had basically a tape diagram. Maybe I should we'll just pretend that it's on the scale. Or I can make my scale bigger. It doesn't really matter. So each is worth 1/10, and all the tenths together, that would give us 10 tenths, is 1 kilogram. Yeah, all right. We got that. These are all 1/10 kilogram, but I don't have enough room to write that. So 10 tenths kilogram, which is 1 whole. 10 divided by 10 is 1. Absolutely, we got that. We know how to do that. How much would 2 bags of rice be? 2 tenths. 3 bags of rice, 3 tenths. If I have 3 tenths bag of rice, how many more until I have, and this is kilogram, how many more until I had 1 kilogram? Well, if I have 3 already, how many more do I need? 7 tenths kilogram. It's really nothing new. This is actually going back to like the easy stuff in fractions, right? So what does this have to do with decimals? Well, I'm going to show you. Okay. Ugh. Man, that is not very straight. Stop. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so each is worth 1/10, right? Now let's find our trusty number line. Yes, I know you don't like it, but guess what? It is useful sometimes. 0, 1. Do you agree? Yes, of course you agree. Because there's no one here to argue with me. All right, so we make our marks here, right? Right where they overlap. And this is worth 1/10, so they're all worth 1/10, right? So we can say that this is 0/10, this is 1/10, this is 2/10. Actually, it's funny, I'm doing this with Charlie right now. He's still on the fraction module, and he'll move on to the next one. I don't even know what it's on right now, but he moves on to the next one on Wednesday. So we're finishing up fractions with him. Okay, yes, you agree? That's how we would have done it up close and personal. That's how we would have done it in school. We labeled that. Now, what does this have to do with decimals? Well, now I'm going to show you how to write decimals. So 1/10, that means 0 wholes and 1/10, 0.1. Now, you're probably going to say, well, can I just put 0.1? Well, we really want the proper way to write it is to put 0.1. Okay, we don't have a whole. The decimal comes after the whole number. That's the big thing to learn, is the decimal comes after the whole number. So since we don't have a whole, we don't have a whole one until we get over here, the decimal comes after. So this is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and this would be 1.0, or just one whole. If you have a whole number, even like the whole number of 5, and you try to put 5.0, you can, but you, if it's 0, if it's only a 0 after the decimal, then you don't have to have that. All whole numbers actually have a decimal after it. We just don't usually write it. That's like a high school lesson there. So anyway, this is 1/10, this is 1/10. So if we look at, and I bet you a lot of you already knew that, but ones, tens, hundreds, whoops, okay, we actually have a column here for decimal. You can see that. And then this would be what's called our tenths. And then after this is actually our hundredths. So that, I mean, we're not really, let me erase this and then I'll show you. Oh, okay, I will do hundreds, tens, ones. Here's our decimal, and this is tenths, and this is hundredths. Now it's not hundreds, it's, and I don't have enough room, but here's, I'll write it down. It has that THS, sorry, excuse me, hiccups, at the bottom, or at the end, excuse me. All right, so if we're looking at this place value chart here, this is how I would, there we go. This is how I would set it up. So maybe we have the 123 and 5/10. Okay, so this is not exactly what I had to do today. Our problem set is actually pretty easy, and you'll understand it. But I just wanted to show you, this is how you set up the place value chart if we were doing that, which of course we will at some point. So if you, I'm going to start doing the problem set now. I wish I could ask you if you had any questions for now, but we have lots of resources where you can ask me questions in our next Zoom meeting too. But anyway, all right. So if you can grab your problem set, now you can't exactly grab it. If you were trying to do this today, you can print the problem set, or you can just write it in a notebook, or you can just view it online. It's up to you. I'm going to have to do a lot of drawing on here, so I'll do the best I can. the first part, or the first one I should say, is shade the first 7 units of the tape diagram, count by tenths to label the number line using a fraction and a decimal for each point. Boys and girls, that's what we just did. Okay, so we start with a tape diagram. 1, 2, 3, 4, 5, 6, 7, 8. Whoopsies. Okay, and then let's make our number line now. It's set to shade in 7. 1, 2, 3, 4, 5, 6, 7. Okay, so on the bottom we have 0 and 1, and they want the decimal first, and then they want us to put, oh, I should have made that higher. All right, so our decimal, that would be 0.1. That means 1/10. This is 0.2. It means 2/10. 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Okay, now let's just do it in fraction form too. 1/10, 2/10, 3/10, 4/10. This is where we're like, oh, that is so easy. 5/10, 6/10, 7/10, 8/10, 9/10. Okay, so this is where 7/10, 7/10, 7/10. That's all we had to do for the first one. So see, that wasn't so bad. And then we are reading. Remember, if I'm going a little too fast for you, you can actually always pause the video, right? You can rewind it. You can go back to it, or just pause me in a funny facial expression. Write the total amount of water in fraction form and decimal form. Shade the bottle to show the correct amount. Oh, it's shade the last bottle. All right, so on the problem set, it shows a picture of like a little jug. I obviously didn't do a very good job. That's fine. And then here, it's actually a number line. And the number line, even though it doesn't have the arrowhead, so I guess I shouldn't have done that, is showing you, that would be 0. And they're showing you 1 liter, okay? And then it shows 0.5 liters. So that means we start at the bottom with our tenths. So this would be 0.4. I'm just going to go backwards. 0.3, 0.2, 0.1, and that obviously is 0 down there. You don't have any water in there, right? And then 6, 7, 8, 9, so 0.6, 0.7, 0.8, 0.9. Now it doesn't actually have, it only has the 0.5, which is 5/10, and it has the 1 liter. But that's okay because we know that it's a number line. It's just turned the other way. So it is showing the water filled up to here, which means that is 6/10 of a liter, and they have the L for you. How do I know? Because it's the line right after the 5/10. So what's after 5/10? 6/10. And then we write it in decimal form, it would be 0.6. Now, do you have to go and label those? No. Can you? Absolutely. I did. And that's actually all we had to do for that. Oops, excuse me. So it's 6/10 of a liter, so not quite a liter. It's pretty close to half, isn't it? The next one, I should have left the jug there. The next one shows, so what you're going to want to do is you're going to want to start at that 0.5. So here's my line again. Here's my 1 liter. Here's my 0.5, so 5/10. And the 6, 7, 8, 9. So this is 0.6, 0.7, 0.8, 0.9. Now, if you look closely, it's right here on the 0.8 liter. But you know what I was supposed to do? I was supposed to put 8/10 liter first. So whoops. So I did it backwards, excuse me. So you are putting it's 8/10 of a liter. And how do you write it in decimal form? 0.8. Okay, the next one, I can't see, actually I can. Oh, the next one, they tell us the decimal form of it already. So that's 0.9. So let's work backwards. 0.9 liters means 9/10. So we can do our fraction. And then we can go on our, remember we're working backwards here, and we go on this. And this one that says 1 liter, well, 9/10 has to be the one right below it. So you can shade in that whole thing up, whoops, up to the 9/10. So this is your 0.9 liters. See, that wasn't that bad. Okay, so now we see a scale. Oh, I'll show you. You know what I can do? I can show you. Yes, this is what it looks like. So we just did these ones. And this was our 9/10, so we go right up to here. And so here's our scale. We have to write it in either the digital form here or the fraction. So they already have the digital here, so now we write the fraction. Well, here they have the fraction and we have to write the digital. Ooh, this is a good one. This is a different kind of scale here. It's not digital. I can't think of what it's called actually. It's just a regular scale, but it has a term to it. I don't know. Sorry guys. There, look, there's our bag of rice. So we have to figure out how many kilograms that is. So the first two, it tells us that it is 0.4 kilogram, or the first one, excuse me. And we know that 0.4 means 4/10. So our fraction is 4/10 kilogram. That's it. Our broccoli and lettuce are 4/10 of a kilogram. Now we have fruit on the next scale, and they told us that it is 8/10 of a kilogram. So how do you write that in decimal form? You're writing it right on the scale if you actually have the paper. That would be 0.8 for 8/10 kilogram. Now that last scale that I still cannot think, oh, it's not a balanced scale, no, because a balanced scale would have one on each side. I don't know, just a scale. Anyway, they have a circle and it says 0 kilograms, right? And then it has it looks like a clock, but it's not done the same way as a clock. 1, 2, 3, 4. They have 1, 2, 3, 4 in between. Well, in between each side. So that means there are 9 here all together. Oh, it's just kind of like our tape diagram that we could do, and we split it, if we're splitting it for 10 pieces, we have 9 marks. So this would be 1/10. This is 2/10. Now right down here, it actually says 0.5 kilogram. So that's 5/10, right? So this is 3/10. Whoops. This is 4/10 and 5/10. Now the scale is pointing to this one. So that means 2/10. And that would go down below. And if we wanted to write it digitally, with the decimal, we'd put 0.2. I'm tripping over my words today. Now the back, or the next page, or whatever you want to call it, shows a ladybug. Now look at that ladybug. See the ladybug? I can see that it's from 0 to 1, so it kind of looks like a number line right there. that long line stands for 5/10, because it's half of 1, right? We've done this before. So if you count all those tenths, you're going to have 5/10. You see where the ladybug ends? It ends pretty much at the 5/10 line. You could say 6/10, but I think it's 5/10. So they want us to write it in fraction form. So that would be 5/10 of a centimeter, and it already has it labeled centimeter. To write it in decimal form, there's our 5/10. And then it says, how far does the ladybug need to walk before its nose is at the 1 centimeter mark? So they're saying if we're at 5/10, how centimeters, how long and how much longer until we get to 1 centimeter? Well, 5/10 plus what is going to give us 10/10, because 1 centimeter is 10/10, right? So we need to add 5/10 to it. So there's our answer, 5/10. So now this next part, it says fill in the blanks to make the sentence true in both fraction form and decimal form. We are basically finding ways to make 1 whole, or 10/10, because 10/10 is 1 whole. So the first one says 8/10 plus, and then there's a blank, equals 1 centimeter. Now 1 centimeter is going to be your 10/10. This should look familiar. I mean, we did stuff like this in fractions and we were like, oh yeah, this is really easy. 8 plus how many more? 2/10. 8 and 2 is 10, 10/10, 1 whole, right? So that's why fractions are super important when you're doing decimals. All right, B is 2/10 plus what? Well, 2/10 plus how many tenths will give you 1 whole? 8/10. So we want 2/10 plus 8/10 gives you 1 whole. C, 6/10 plus what equals 1 whole? You guys are sitting there going, this is really easy. Yes. Yep, you already know this stuff. The big thing today, use metric measurement to model the decomposition of the whole into tenths. Basically what we did today was show the fraction to decimal, what the actual decimal looks like and how to read it and how to make 1 whole. So 4/10 gives us 10/10, which is 1 centimeter. Now we have our decimal, but don't worry, it's pretty much the same thing. You have 0.8, which means 8/10. How many more tenths do we need to make 1 whole? We need 2/10, so it's 0.2 equals 1.0 cm. Now, do you really need to put the 0.0? No, but they wanted to show you that, okay? So 2/10 plus how many tenths more gives you 1 whole? It would be 8/10. So, oh look, they just flipped those around. 2/10 plus 8/10 gives you 1 whole. And then the last one, 6/10 plus, oh, I did this last year too, plus 4/10. I forgot, A was supposed to go all the way across. So we were supposed to be writing 2/10 in both fraction form first and then decimal form. It doesn't really matter. We still did all the answers, but sorry about that. Now on the bottom, all you have to do is draw lines. So I'm not going to do that on the whiteboard, but I'll show you what the bottom is. The bottom part, and you're like, oh my gosh, this is so easy. The bottom part here shows, oh, it's hard to do this. 3/10. Well, there's 3/10 and there's 3/10. So 5/10. Find the one that's 5/10. There's 5/10. And there's 5/10. So you draw a line here to here and then here to here. 6/10. 6/10. 6/10. And there's our 6/10 in decimal form. 9/10. Here's our 9/10 in fraction form. And here's our 9/10 in decimal form. And then 2/10. Here's our 2/10 in fraction form. And here's our 2/10 in decimal form. That's it. All right, until tomorrow, guys.